Hello, my name is Isaiah, and I'll be talking to you about the Physics 2211 Lab 1 Constant Velocity. In this lab, we will observe the motion of an object moving at constant velocity and compare that observed motion of the object to the predicted motion of the object. There are three physics concepts that go along with this lab. The first concept is constant velocity. This means that there is a net zero force acting on the object, which leads to no acceleration, which would lead to the velocity staying constant. The second concept is Newton's first law, also known as inertia, which is that an object at rest remains at rest, or if it is in motion, it remains in motion at a constant velocity unless acted on by a net external force. And the last concept is the formula used, which is the position update formula, which states that the final position is equal to the average velocity times time plus the initial position. The results of this lab have proved the first law of Newton's postulates. So initially, we had to find the motion of an object and observe it. So this is a screen clip from the tracker that shows the marker's motion as observed. Initially, we have to start with the surroundings. There's a flat table, there's a meter stick to measure distance, and a camera to measure time. The tracker, as you can see here on the right of the screen clip, has a table with data and a plot for the data. The analysis shows that the distance between the time intervals is approximately equal. So this would show a linear relationship, which would prove that there is constant velocity. And that there is error, and we tried to eliminate error by using smaller distances, such as half a meter. So this is a computer model showing the predicted motion of the marker. As you see on the left, there is a glow script that is showing, based on the initial velocity and the time of the recording, what the position of the marker should be. As you see on the right, there's a table that took the output of this program and listed all the times and positions that are the same, that would start at the same time as the observed motion. And you can see the graph below, which graphs the time versus position to show a linear relationship portraying constant velocity as shown by the computer model. So in order to calculate the average velocity, we took the change in distance over the change in time from the video, and that's what we use as the average velocity. And again, for the final position, we use the position update formula for each time interval in order to figure out what position it would be at to find the constant relationship. As shown here, the observed motion versus the prediction motion. The predicted motion is the line in blue, and the observed motion is the line in red. Our conclusion shows that both equations are comparable to the position update formula, and that Newton's first law is true for both models. However, as you notice in the observed motion, there is a little bit of error, but that comes from the friction in the table and possibly air resistance as well. Here's a reflection. What if the axes were flipped? Well, if they were flipped, you would see an inverse relationship between time and position. You would see, instead of a positive slope, a negative slope with the exact same magnitude. What does all of this mean? Well, as you see here on the right, this is a free body diagram of what the marker, even though it is a box, looks like as it moves. The velocity is shown in yellow as it moves to the right at a constant velocity. The weight of the object and the normal force perfectly balance out, so there's no movement in the y direction. However, there is friction, which will slow down the velocity, and that is the difference between the observed motion and the predicted motion. Thank you.